The trapezium rule is a numerical method of finding the area under a curve. We've seen how we can use numerical methods to find a root, for example, using the decimal search or by using the iterative method. But finding an area is essentially integrating a function. Okay, let's take an example. If we look at this function here, 1 over x squared plus 1, we can see that's a complex integration sum. Okay, we don't have the tools to be able to do it algebraically. It's a 1 over x, except it's not x, it's x squared plus 1. And we can't write the x squared as 1 as an ax plus b form, so we simply don't have the tools. So how would we be able to estimate the area of this curve? Well, let's see. If we draw an axis and we draw a rough approximation of our curve, and we say, right, we want to integrate, we want to find the area from a, x equals a, to x equals b. We could say that this distance here, we could call it h, which is just b minus a. And then, what is the height of this guy? Well, the height is f of a. It's our function, 1 over x squared plus 1. We put a into that function, and we get the height of our, I call that a fence pole. That's a pole there. And then we've got f of b on this side. Now, if we wanted to find the area, why don't we just approximate our curve using a straight line here? And if we were to work out the area of this trapezium, we'd be estimating the area of our under our curve. So what is the area of a trapezium? Well, from XE we'll know it's simply the height times the average of these two. So it's, we'll say f of a plus f of b divided by 2, and then the whole thing times by the height. And so we can approximate the area under the curve. But don't forget we're missing this little piece over here. It's only an estimate. If we wanted to make it more accurate, why don't we put another trapezium here? And we could say, right, now we're getting a much closer estimate. And so it could go. We could divide it up into a whole lot of trapeziums if we wanted to. We could sum up the area of each one, and that would be, basically that embodies the trapezium rule. This is how the trapezium rule is expressed. We have some y equals the function of x, okay, and we're trying to find the area under this, so we're trying to integrate the f of x, y, from x naught to xn. We've divided all the little x's depending on how many trapeziums we actually want. And the width of each trapezium is given by h. Now what is h? Well, h is b, the last x minus a, so it's b minus a, divided by the number of trapeziums that we're wanting. And there we have it over there. H equals b minus a over n. N is the number of intervals. It's quite simple. Right. So what is the area of my graph from this point right through to this point? Okay. It's going to be, so the integral from a to b of my function y is equal to, now it's the half times the height, that's the height, times y naught plus y1. So there's y naught plus y1 divided by 2. Okay, there you see my 2. So that's my first one. Then plus a half the height times y1 plus y2 divided by 2. Okay, so each one of these is essentially the area of all these little rectangles that are now being added together. But if you look carefully, you'll see there's a y1 here and a y1 here and a y2 here and a y2 here. They're all divided by half. So all the middle fence poles, these middle guys, are all twice. They occur twice, whereas the outer two, your y0 and your yn, only occur once. And that means the equation reduces to a half times the height times y0 plus yn, so they occur once, plus 2 times all the middle fence poles. Okay. And if you now work this out, add this all together, you're essentially estimating the area under the curve. And that is what your trapezium rule basically defines it. Now, the trapezium rule, you need to remember this formula. Okay, it's not going to be in the formula sheet. It's quite simple. It's a half of this fence pole plus a half of that fence pole plus the sum of all these guys times h. And h is simply your final x value minus the start x value divided by the number of intervals. Now just be careful. There's some terminology you need to be aware of. A trapezium rule has n intervals. Okay, that's how many trapeziums you've actually been asked to divide the area into. So the exam question might say divided into 3 intervals or 5 intervals. So that means you've got 3 or 5 trapeziums that you need to add up. But if they say you must the integration must have 5 ordinates, they're actually saying how many fence poles you must have. Okay, if they say 4 ordinates, it means that you've got 3 trapeziums. So just be careful. The terminology, an ordinate is how many fence poles there are, and the intervals is how many n is how many intervals you have. And so when you work out h, you must divide by the number of intervals, which is always 1 less than the number of ordinates. Using our example, we're now going to implement the trapezium rule in a practical way. So we've been asked to integrate from 0 to 1 of this function 1 over x squared plus 1. Okay, so first of all, we see that the x naught value is 0 and the xn is 1. Okay, there we have them over there. So that's our start and that's our end. We've been asked to do it over 5 intervals. Okay, so that's how the question was phrased, n equals 5. So first of all, we can find y naught. If we put naught into this equation, we can see that y naught is 1, and that yn, if we put 1 into that equation, we get yn, or y5 equals 0,5. Because these are the outer 2 fence poles, we add them together and we write them down over there. Then we look at all the intermediate fence poles. Okay? We can say that h equals b minus a over n. That's equal to 0,2. Okay, so we've got, that's our b, where the final value of x, that's our a, we subtract it 2 and we divide by the number of intervals. That gives us the 0,2. So the x1 is going to be the start x plus h, 0,2. The next one will be plus another h, okay? It's not that this is always going to be 0,2. It must be added to your initial value of x. And so we can find the intermediate fence poles by putting 0,2 into that equation, 0,4 in there, etc., etc. Once we've got all our y values, we can then add them up. And in this case, we need to double them. Okay, the intermediate ones you double. You put it down there and then you add the 2 together. So now we've done all the summing necessary for the trapezium rule. And then what is the final answer? Well, we're going to say it's a half times the height times the sum of all the outer fence poles and double the inner fence poles. And that gives us our estimate of 0,784. So it's quite easy to do. Just need to remember that it's got to be done in a structured way. You must be able to check your work. The marker must be able to see that you understand how it's the outer fence poles plus 2 times the inner fence poles. You sum them all together and you times it by h over 2. That's really quite simple. Then what about the accuracy of the trapezium rule? Okay, it's very difficult to actually check that because we weren't able to integrate it exactly. But one thing we can see if we've overestimated or underestimated. And that's just by looking at the shape of the curve. If you take this curve, you'll see if we put a trapezium there, that is the estimate of our area. Okay, but the actual area includes that little bit. So as long as the curve is downward facing, we're going to be underestimating. So you need to get some sort of idea of what the shape of the curve looks like. And similarly, if the curve is upward facing, our estimate's going to have a trapezium area of that, which is actually bigger than what it actually is. So our answer is going to be a slight overestimate of what's required. So in an exam question, they would say, look, find the area, estimate the area using the trapezium rule with so many 4 intervals. Okay, n equals 4. You look at your start point, your end point, you divide it up into your fence poles, and basically you can find the area. And then they'll word something to say, was this an overestimate or an underestimate? And you just need to look at the shape of the graph. If you're not sure on the shape of the graph, you can do a double differential. And if y double dash is positive, then you can see it's upward facing, and you'll be overestimating. Whereas if y, the second derivative, I call him y double dash, if y double dash is negative, it's going to be downward facing, and you've got to underestimate. What must you know? First of all, the equation for the trapezium rule. And how to put that together is important. You need to have this equation off pat. Okay, you need to understand that and also be able to memorize it and just be able to do it. You don't want to be working it out in the exam. So that's very important. They will normally tell you how many intervals you need, and from that you can determine what your steps are in your x value. In other words, what is h. And then there's a distinction between n intervals versus n plus 1 ordinates. So there's always one extra ordinate, one extra fence pole compared to the number of intervals. So if they give you the ordinates, just subtract 1 and you've got the number of intervals. And then you need to recognize if the curve is upward facing or downward facing to see if it's a over or underestimate. So thanks very much. The trapezium rule is quite a short section. It's quite straightforward, but just be careful with your calculations. Thanks very much for listening, and if you've got any questions or you've got any comments, you're most welcome to contact me. Thanks very much. Bye.